Okay, next part of this course is data visualization. Now, we discussed what is data, what are data scales, what are the some statistics, and how do we describe the data, descriptive statistics we discussed. In descriptive statistics, we also took one point, the fourth point, and the last point was data visualization, which is the graphical representation of data. Why do we need to present the data in a correct form? There are certain reasons for this. The creation and study of visual representation of data is known as data visualization. This is actually definition of data visualization. Number one is functionality. There is some function that data is trying to accomplish. The data we need to see the true value, or the true value actually the values are random values whichever we have observed. We need to find the average which should be close to true value. If we are having different samples and we need to find the averages of all this, we need to see the variance. There is some function associated with that. Okay. Functionality is the basic or the fundamental use for what purpose is data being used. We can draw histograms, we can draw scatter plots, what and where to draw, what are the various applications and which is not recommended at what place, we will discuss these things. Okay. Now, next is aesthetics. As you know, in data visualization we also plot the data in different colors, different sizes. We can show different, we can also cheat with scales, cheating with scales, I will discuss that. So, all those things is aesthetics. Number first plot is the bar charts. Bar charts are just as we discussed, these are the bars like these. Okay. If I say let me say height and weight, I can have different colors here. I will use it here. This is bar 1, okay. This is bar 2. Different components are there, and I am discussing about the height and weight. I can just see that the height of the component 2 if it is larger, then weight is also higher. We can find the correlation, I can just think of some correlation between them. But bar charts is the very commonly used graphical representation, and we can have two types of bar charts. Those are stacked bars and spread bars. And spread bars. Okay, these are actually stacked bars. We can have sample number 1, 2, 3, okay, but we call it item number 1, 2, 3, 4. These are known as spread bars. I can have number of items from 1, 2, 3, number of observations from 1, 2, 3. This is spread here, okay. This is spread here like this. This is spread here like this. Weight is also proportional. Okay. So, I can use height maybe is in mm, weight is in grams. However, this is not a very proper way of representation of two different entities on one scale, but yes, if I even use this only, okay, it is also a bar chart. This is also a bar chart, okay, and this is a spread bar. Stacked bar is when we are stacking one bar over other. When we are stacking like this. Okay. Now, we can just plot the temperatures, different temperatures. For instance, if the scale here is temperature, like if this is temperature here, temperature degrees centigrades, I will use a spread bar like this, okay, to show that the temperature is varying. Actually, the more appropriate for plot for temperature would be the line diagram, but the temperatures cannot be like this. If I put temperature degree centigrade here, this is not recommended. We cannot say that the temperature 20 degree plus temperature another 15 degree, this is 20, let me say this is 35, this is 20 degree total, this is 15 degree, that makes it to 35 degree. Now 20 degrees of temperature plus 15 degrees of temperature is not equal to 35 degree centigrades. Okay. So this is not recommended here. However, if they are heights, or even say if the number of pieces that we have inspected, and we are we are just making the note of the pieces, those are being inspected, those are being checked in each hour. Okay. In first hour, let me say I inspected 5 pieces. In the next few hours, I inspected further 3 pieces, that makes it to 8. In the next few hours, I inspected 4 pieces, that makes it to 12. Okay, this is 4, this is 3, this is 5. In that case, stacked bar can be used. Okay. So we have to be very careful that which kind of chart or which kind of graphical tool are we using for our data. We just cannot pick anything and put any data over there. Okay. So next is the histogram. Histogram is a special type of bar chart that shows the frequency of the data values, number 1 to visualize the data distribution of the data values, and number 2 to know that how large the spread is. Histogram is a kind of a bar chart. As we discussed in the frequency distribution, we have some interval here. Okay, let me say if this is again height in this direction, and we are having frequency in this direction. This is a kind of a frequency distribution again. Okay, let me say height from 0 to 10. Okay, this is, let me say 0 to 10. Again I am having from 10 to 20, then for 20 to 30, and so on. If I am having such kind of plot, this is known as histogram. 70, 80, let me say the minimum value is 0, maximum value is 80 here. Okay, this might be the height of any component that we are trying to see. There are certain guidelines to draw the histogram. We cannot just divide the intervals into any number we like. Okay, if they are 80, for instance, let me say if they are 800, height varies from 0 to 800, then what do you think? Should I have the interval of 10? If it is from 0 to 800, and if I make an interval of 10, okay, the total would be actually 800 minus 0 by 10, this is equal to 80 bars. So it is not very legitimate to draw 80 bars in one chart. So there are certain guidelines for this. Number 1 I can put here is histogram has to fit onto the paper. Fit onto the paper. If I try it on the paper, if I am even using softwares, then also the 80 bars is not a very great idea to use. Then next point I can put here is it should accommodate all the observation. It should accommodate all the observations. Okay. It should accommodate all the observation means all the 800 values from 0 to 800 has to be accommodated. Then we need to fix the number of bars that we use to draw the histogram. The recommended number of bars is from 3 to 13 bars. This is ideal. This is ideal. 3 bars to 13 bars. We can even move or go beyond 30 bars if we like, but 3 to 13 is an ideal, or the I can say the best selection of the histogram as a graphic tool. Now the intervals here must be defined very clearly. Intervals are to be clearly defined. Okay. So, we should be able to at least compare the histogram with the other graphs. So, okay, it has to be comparable, has to be comparable with other graphs. So, more we have the number of observations, the more bars we can draw. In general, it is 3 to 13 bars are the ideal ones, but also we can have more number of bars if we need to select only a small interval, if there is no other way to do that. Sometimes those cases also occur. Now, an interesting thing I like to discuss here is, with histogram or with bar chart, we can cheat with scales. For instance, if let me say I need to represent that the height is height from 0 to, let me say 150, okay, you call it 150 centimeters. Okay, let me call the height of the human beings, height of the workers who are working in my machine to lab. Okay, the height of the men, let me call, and height of the women. If I show this, okay, the maximum height of the men here is, let me say, at 150 is a small number. If I took the Indian standard, I might put 165. For women, it has to be 148. Okay, let me say this is the height 165, 148. This is one way. Another way is, if I do not start it with 0, I start it with just 140 to 170. I have 150 and 160 here. Then I can say that height for the women would be close to here 148, and height for the men would be here. So, it looks like that this value is high, this difference is high. We can cheat with scales in case of bar diagrams, okay, by just changing the scale here. Okay. This is known as cheating with scales. So, it depends sometimes in marketing, it is very deceptive sometimes. When they need to show the cost savings, they will show, okay, this much big saving is there. Okay. When they need to show that defects are defects are reduced, they will show the big difference. Where they need to show that there is a small difference, well, they say cost rise, they may show this, okay, there is a small cost rise only. Okay. These things are deceptive sometimes. Now, next is the pie charts. Pie charts, you people might be knowing, it is like your pizza pie. We can divide the data into various sectors here, okay, and we cannot cheat. Okay. We can not cheat with scales here, because this whole data, this whole pie is 100%. So, these are often used to show how much contribution a part of each group represents. So, the pie charts, a typical example I can put here is, okay, you divide this course, say 30, this is 30 hours course, you can divide it into sections. How much time is spent on the specific, let me say, linear measurements, linear or angular measurements, how much time is spent on laboratory demonstrations. They can say, let me say 33%, okay, put laboratory demonstrations, let me say 30% on this, okay, let me say then 25% on statistics, stats in metro. Then let me say 30, 25 is 55, 20% on maybe introduction of the course. Then I can divide that to 30, 25 is 55 plus 20, 75 plus 15 plus, okay, 10 plus 10 plus 15. Oh, okay, I can say, okay, this is on the thermal instruments, this may be on optical instruments. But the thing is that the whole pie chart is containing the complete data set. It is 100% in total. We can also put numbers. The pie, we cannot cheat here. It is just representing the whole figure. So this is used to represent the contribution of each sector to the overall area. Okay. So next I have here is scatter plots. Scatter plots are very important. Scatter plots are well suited to show the relationship between two variables. These can be cause and effect, and they can be correlation. The cause and effect and correlation. We can have scatter plot like this. Okay, let me say if I am having in my metrology lab, I am trying to measure the force, or I am trying to measure the hardness. And okay, I have to put it in the other way then. Hardness and wear. When I am testing some specimen for wear, the hardness is increasing. For more hardness, I will see the wear would be less, and for less hardness, the wear would be higher. You can see this kind of scatter plot here. Okay. When the data set is having more than 20 observations typically, so it can be like this number can vary, but we having number of observations. So it is not recommended to draw one line like this, such a big, all these points in one line. So scatter plot is giving you the broad idea that what is the major trend. I can say, okay, this is a kind of a negative correlation. I can put the correlation coefficient here close to minus 0.8, okay, minus 0.8. So this is the use of scatter plot correlation, sometimes cause and effect, sometimes the correlation is 0 and we just have the scatter plot like this. Okay, this is correlation 0, but it is interesting that sometimes the non-linear curves are there, and if the scatter plot is like this, here also the correlation coefficient is equal to 0 in both the cases, in this case and in this case. Here it is actually there is no correlation, but here in case 1, this is case 2, in case 1 we have the correlation, it is first increasing then decreasing, but it is non-linear, it is having some curve here. Okay. So correlation coefficient does not work, but yes, scatter plot can be used to find the rough idea what kind of data do we have. Okay. Next is line charts. Line charts are often used to illustrate a trend where x is variable. Now line charts are just drawn simply like this. For instance, I am having age of the instrument and number of defects. Okay. It can be like this, first point, second point, third point, fourth point, fifth point, sixth point, it can be like this. Okay. We can see with age the number of defects in any instrument. If instrument is used for, let me say, 40 years, I can say the number of defects or number of defective observations also are being taken from then. This is an increasing trend, it is showing an increasing trend here. Okay. So, line diagram is also like when we plot the control charts for X bar charts, we draw the line diagram to see whether do we have outliers or not. So, we will see that in control chart we have this center line here, we have this upper control limit here, we have the lower control limit here, we have this center line. Okay. Then we at each observation that we are having in a day, we will just put the value here. Okay. We put value of 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. Then if we draw this line diagram, we can see that it is having this kind of trend. This is one outlier that has come 1, 2, 3, 4, 5, 6, 7 and 8, that has come at 8th location. Okay. Also sometimes in line diagram we can see that, okay, if this data is like this, sometimes there is a peak like this. What is this? Why this peak has occurred? We can work on this as well. Okay. This is a peak, or you can say, better I will call it spike. This is spike. Why this spike has come? Okay. In line diagram also we can cheat with the scales. If we need to show less variation or more variation, we can just cheat with the scales. For instance, if I need to show the age, that the trend, I need to show that the trend is smaller, the slope of the trend is lesser. If I need to show the slope of the trend is lesser, I can widen this thing. Okay. I can widen the horizontal scale here. I can show age from 0 to 50 years. Okay. Here I can show the age from 0 to 10 years. If from 0 to 15 years it is like this, 0 to 50 years it is like this. Okay. There is a slope that is increasing like this. For 0 to 10 the slope would be seen a little higher. Okay. This angle would be greater, this theta value is greater than this, I call it phi value. Okay. Theta is greater than phi and I can show that the slope is high. So, this is always there, cheating of scales can happen. Next is bubble plot. Bubble plot, it is a kind of a scatter plot, but we can also introduce another dimension into it. Another dimension, by another dimension I means another variable. For instance, I am talking about the weight and height of maybe workers, and also I am in place of the dots, those who are in scatter plots, I am putting bubbles. Okay, where these bubbles represent, the size of the bubble represent the maybe age of the person. Okay, I can put size of bubble is equal to age of the worker. So, bubble plots are used to induce a third variable. However, we can also have 3D plots like surface diagrams. Okay. And there are certain other ways to represent the third variable. Bubble plot is one that in 2 dimensions we can just see the value of or the field of the data here. Next plot is box plot. From statistical viewpoint, box plot is very important. What is box plot? We divide the data into quartiles. This is my box plot. Okay, I divide my data into quartiles. This is my lowest observation. And this is my highest observation. And as I discussed, this is my median and this is Q1 and Q2. That means I am having 25% of data here, 25% here, 25% here and 25% here. This is my box plot. Just I am putting the dimensions here. This is 25%. This is 25%. 25% of data means 25% of values lie in between. If there are 30 values, 30 value means okay, if I have 40 values, 40 value means 10 values in each of these. Now these lines, this line is known as whisker. This is known as whisker. Like animals have whisker, which is a long hair, like in the mustache. So this is that kind of whisker, which is a long extended line. Okay. So this is also known as box and whisker plot. So what is the significance of the box plot? Actually this is median here. We can see the location of the data. Where is our data trying to being located? For instance, I can have boxes here in my data. Okay, let me say this is like this. Okay. So an example can be, this is cost of maintenance from different customers, and this can be the model of car for a specific company. Like, okay, let us say for Maruti there are certain models there. It can be Maruti Desire, it can be Maruti Eco, Baleno, Celerio, Ertiga, like those. Okay. So what is the cost for the customer? Let me say for 100 customers. For each data there are 100 customers. Okay, for 1, 2, 3, 1, 2, 3, 100 persons per box plot. So we can see that in this case the median, the central data is quite toward the lower side. It is in toward quite for the first case it is quite on the upper side. It is also in the upper side in the third case. So this kind of box plot can give you rough indication. Even I can draw, I can join the median points here, straight lines. So this is, if I am having number of plots like this here, this is an extension of my line charts. Okay, the line chart is the green color and the box and whisker plots are giving the more detail of each point here, each data here, each data point here. So this is box and whisker plot, and we will use this when we will do further other discussions. And next is dot plot. Dot plot is recording the data as and when it is happening. Like okay, I will took the example of the cars only. Cars are coming to the service station to get serviced, and each car they get their service, they just need to notice that how many cars are they, how many different models are they are servicing each day. So they can put here different models. Okay, they can put these into different bins. Okay, I can even have some pins here and keep putting rings over here. Okay, let me say this is these are models of Maruti car, Maruti Desire. This is Celerio. This is you call it Maruti Ertiga. Then Maruti Eco. You can put any model like those. This is Estilo. So each car they are servicing, they are putting a ring here. They are putting a ring here. Okay. For in a day, then getting each car they are putting a ring over here again. Okay, they are getting one Celerio putting ring, they are getting one Ertiga they are putting ring. Just recording the data. So this kind of plot can also be put like this: 1, 2, 1, 2. Okay, I am putting rings here. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 1, 2. Okay. So, this is dot plot. Now, next in data visualization, next comes is tables. Tables, as we know, those are very common. We have been using those. Table is a kind of a matrix in which you have rows and columns. It is important to have the tiles for the columns and the tiles for the rows as well, and the overall title of the table. So, in tables also we can represent it percentages as well. For instance, if this is some table, we are having a title for row, we are having title for the columns here and the title for rows here. Okay, we are having some data, we can put that data into percentages as well. So, all those examples can also be taken into account. So, percentages, these are sample frequencies or sample percentages. Sample percentages are directly comparable to the population percentages, and assesses whether the sample is representative or not. Use percentages with caution when sample is small. Now, percentages can also be used to represent the data or to present the data in the form of a table. In the, for instance, if I put the numbers here, let me see, I put age group here, if I put age varying from maybe 12 to 13, then 14 to 15, then 16 to 17, let me say this is 5, 6, 2, and these are two things here, 2 points in the category girls and boys. Okay, 5, 6, 2 girls, 5 girls are from age 12 to 13, 6 from 14 to 15, and 16 from 2 from 16 to 17. Similarly, I can have boys 6, 8, 3. Total here is 5, 6, 2 is 13, 17. Overall total here is 30. Okay, and here also I can have the total. 5 and 6 is 11, 6 and 8 is 14, 2 and 3 is 5. The overall total is from this side or this side. This table has to have the heading. This is number of kids in a you can say call it crèche. Okay. Then we have the age here. This is age and this is age. Okay, this side we are having age. Then we are having their gender here, or I will call it their sex here. Okay, this is the table. This data can also be represented in the form of percentages. The percentages, if the data is like this, I can choose in place of 5, I can put the percentages in the same table. This is actually 5 by 30, 5 by 30 is 16.7%, 6 by 30 is 20%, 2 by 30 is about 6.7%, this is again 20%, this is again this is 8 by 30 is 26.7%, and this is 3 by 30 is 10%. Now, this kind of tabular formulation is used for goodness of fit. So, this is data visualization. Next, I will take you to the demonstration part of this lecture. We will discuss how to plot these graphics that we have just discussed. So, just to recapitulate, we discussed the descriptive statistics in the last 2 lectures, and we discussed the important measures of central tendency. Okay, that was the mean, median, mode, and then measure of dispersion. Okay, then we discussed locate the position. We discussed quartile and percentiles. Measure of dispersions were then range and standard deviation, variance, and also we discussed the uses of data visualization and different data visualization tools or graphs that we can use. Now, we will meet in the next part of the lecture. We will plot the graphs, and then we will discuss about when we will take our frequency distribution forward to the distribution of the data. Thank you.